Okay, now let's look at some examples using the chain rule. So for the first one, f of x equals x squared minus 5x to the fourth. So remember, the easy way to think about this is think of this inside function as if it's just a blob. So here I'm going to say that blob is equal to x squared minus 5x. So now we know f of x is just blob to the fourth power. So by the expanded power rule, f prime of x is equal to 4 blob to the third power times the derivative of the blob. So we need to find the derivative of the blob, which we know in this case, since blob is x squared minus 5x, then blob prime, or the derivative of the blob, is just 2x minus 5. So now we can just substitute into our formula for the derivative. So f prime of x then is going to be 4. Blob was x squared minus 5x to the third power times the derivative of the blob, so times 2x minus 5. And now we need to just simplify this and clean it up. So to simplify it, notice we have x squared minus 5x inside the parentheses here. So there's a common x we can factor out of that. But you have to be careful. Remember, when you're factoring that x out, this is really x times x minus 5, all raised to the third power. So remember, if you have a product that's raised to a power, that power is going to distribute through to both pieces. So this is really 4x cubed times x minus 5 cubed times 2x minus 5. And so then now, to finish cleaning this up, and this last piece is optional, I usually am going to move the factor that's to the first power. I'm going to move it to the first spot. So I'm going to make this 4x cubed times 2x minus 5 times x minus 5 cubed. Now, you don't have to do that, but it does make it just a little bit cleaner whenever you're looking at the final answer. Okay, so example 2. So y is equal to the square root of 3x plus 1. So remember, this is the same thing as saying y is equal to 3x plus 1 to the 1/2 power. So now it looks like what we just did a second ago. So we know in this case, this is really just blah to the 1/2 power. So if we write it like that, this is blah to the 1/2 power, where that blah is equal to 3x plus 1, our inside function. So then we know we're going to need blah prime. So blah prime is just 3, since that's the derivative of 3x plus 1. So y prime then is equal to 1/2, so bring the power down, times blah to the 1/2 minus 1 power, or so to the negative 1/2 power, times blah prime. And so then let's go ahead and simplify this before we substitute back in for the blah and blah prime. So this is 1 over 2 square roots of blah times blah prime. And so since it's times blah prime, I can just write that blah prime in the numerator. So y prime then is equal to 3, which was blah prime, over 2 square roots of 3x plus 1. And we're done. Alright, so the next one, f of x equals negative 8 over x minus 5 squared. So this is the same thing as saying that f of x is equal to negative 8 times x minus 5 to the negative second power. So now, same idea. So I'm not going to write the blahs out, but it's the same method of thinking. So blah is that inside function. So then the derivative of this, f prime of x, is equal to negative 8, so constant, times now the derivative of x minus 5 to the negative second power. So that's negative 2. Blah stays the same, so the inside stays the same, x minus 5, to the negative 2 minus 1, so negative third power, times now the derivative of that blah. So the blah was our x minus 5, so the derivative of x minus 5 then is just 1. And so that's our derivative. Now just cleaning this up a little bit, so this gives us positive 16 over x minus 5 to the third power. Now this one you should recognize because this is the one that we did the long way in the last section when we were using the quotient rule, finding the second derivative. So this is the same answer we got, but it was a whole lot simpler using the chain rule. Alright, example 4. So y equals sine squared x. So remember, now when you're looking at this one, this is really saying sine x quantity squared. So remember, anytime that you have the exponent attached directly to the trig function, we just put it there to make it cleaner. But it's really saying sine x quantity is squared. So this is really just blah squared, right? So now we know, okay, so y prime then is the derivative of the outside function. So the derivative of blah squared, which is just 2 blah, where blah in this case we know is our sine function. So this is just 2 sine x, so blah is sine x, times the derivative of blah, so the derivative of sine x, which is cosine x. So y prime in this case is just 2 sine x cosine x. So let's look at the next example. What's the difference between the one that we just did, so y equals sine squared x, and this next one, y equals sine of x squared? So notice, looking at it, the difference is going to be where that squared is. So in example 4, that squared was attached to the trig function. So that's what told us this was sine x quantity squared. Looking at example 5, there's no parentheses around sine x, so that's telling us that squared is attached directly, in this case, to just the x. So this is really saying sine of x squared. So now our blah is actually what's inside of the sine function. Our blah is the x squared. So if blah is x squared, so we know we're going to need blah prime, which is 2x. But then, so if we rewrite this, y equals sine of blah, so then y prime is the derivative of sine of blah, which is cosine blah, so differentiate the outside, leaving the inside alone, times the derivative of blah, so times blah prime. So now y prime is just going to be cosine of x squared times 2x. And just cleaning that up, we always put the trig function last, so this is just y prime equals 2x cosine of x squared. And we're done. There's not anything else we can really do to simplify this one. Alright, so for the next one, h of x equals x squared times square root of 16 minus x squared. So we're getting a little more complicated now. On this one, we have a product rule and a chain rule together. But first, we have to do the product rule because x squared is just a function times another function, right? So x squared times square root of 16 minus x squared. So we have a product, so we have to do the product rule first and foremost. So h prime of x. So product rule tells us first function, which is x squared, times the derivative of the second function, so times the derivative of the square root of 16 minus x squared. So now this is where we've got to use that chain rule. So remember, if we rewrite our original h of x as x squared times 16 minus x squared to the 1/2 power. So looking at that second function, 16 minus x squared to the 1/2 power, or blah to the 1/2 power. So then this is the derivative of this is just going to be 1/2 times blah, so the inside stays the same, 16 minus x squared, to the negative 1/2 power, times the square root of 16 minus x squared, or sorry, times the derivative of 16 minus x squared, which in this case is just negative 2x. But are we done? We're not finished yet. So that looks like a lot of stuff, and it is a lot of stuff, but we're not finished. You still have to do the second step of the product rule. So plus now, the second function says plus square root of 16 minus x squared times the derivative of the first function, derivative of x squared, which is 2x. So now we can clean this up a little bit. So the 2's cancel. So 2 times 1/2 is 1. And so we're left with a negative x cubed over the square root of 16 minus x squared plus 2x times square root of 16 minus x squared. To finish simplifying this, we want to go ahead and get a common denominator and do the addition. So common denominator is going to be the only denominator we have in this case, square root of 16 minus x squared. So this ends up becoming negative x cubed plus 2x times 16 minus x squared. So remember, multiplying square root of 16 minus x squared times square root of 16 minus x squared over square root of 16 minus x squared. And so then since you're multiplying the radical squared, then you end up, the radical cancels out. And so we're left with all of that over square root of 16 minus x squared together. And cleaning it up, so the 2x times 16 gives us 2x, gives us 32x minus 2x cubed. So at negative x cubed minus 2x cubed gives us negative 3x cubed. So we're left with 32x minus 3x cubed over the square root of 16 minus x squared. And there's not really anything else you can do to simplify this anymore. And so you're finished. Okay, so let's look at the next example. H of x is equal to x squared over x cubed plus 2, all of that squared. So same idea as before. So we want to figure out our blob, our inside function in this case, is x cubed or x squared over x cubed plus 2. So if blob is that, then to find the derivative of blob prime, then we have to do the quotient rule. So low d high minus high d low all over low squared. Or in this case, so low is x cubed plus 2 times the derivative of the top, so times 2x, minus high d low, so minus x squared, times the derivative of the bottom, which is 3x squared, all over the denominator squared, so all over x cubed plus 2 quantity squared. So let's go ahead and simplify this before we try to find h prime of x using the chain rule. So distribute through the 2x, so that's 2x to the fourth plus 4x minus 3x to the fourth. And still all over x cubed plus 2 quantity squared. Combining like terms, we end up with 4x minus x to the fourth. Or sorry, x to the third. Nope, sorry. 4x minus x to the fourth. All over x cubed plus 2 quantity squared as our derivative of our blob. So then, since we know h of x is equal to blob squared, so by the chain rule, h prime of x is 2 blob to the first power times blob prime. So that's going to be 2 times the blob was the x squared over x cubed plus 2 times the derivative of the blob we said was 4x minus x to the fourth over x cubed plus 2 quantity squared. And so let's simplify this. So factor out a x from the 4x minus x to the fourth. Go ahead and bring that in with the other x squared and combine our denominators. So we end up with 2x to the third times 4 minus x cubed all over x cubed plus 2 to the third power. And that is h prime of x in this case. Alright, so now let's look at example 7. So f of x equals cosine squared of 4x. So in this case, we actually have to do a chain rule inside of a chain rule. Because if we think about it, then we know we can rewrite this as cosine of 4x quantity squared. So if we think about it in a traditional sense, our blob in this case would be the cosine of 4x. But then when we go to take blob prime, well, we have that 4x that's inside of the cosine. And so to deal with that, we have to do the chain rule inside of the chain rule. So let's go ahead and find blob prime. So we know 4x is inside here, so this is cosine of blob. So then we know this is going to be cosine's derivative. So the derivative of cosine, which then is negative sine. The blob stays the same, so negative sine of 4x times the derivative of that inside function. So the derivative of that, which is going to be 4. And so then our blob prime is negative 4 sine 4x. So now we already know, so f of x is just blob squared, where blob was that cosine 4x. So f prime of x is going to be 2 blob to the first power times blob prime. So 2 times cosine 4x times negative 4 sine 4x. And just cleaning that up, we end up with negative 8 cosine 4x sine 4x for our f prime of x. Okay, example 8. So we have f of x equals e to the 1 minus x. So think of this as e to the blob. So then f prime of x is going to equal to the derivative of e to the blob, which is e to the blob. So e to the 1 minus x stays the same, times then the derivative of that blob. So the derivative of 1 minus x, which is just negative 1. So then cleaning this up, we end up f prime of x is equal to negative e to the 1 minus x, and we're done. One last example. So example 9, we have y equals 4x cubed e to the negative x. So on this one, we've got to do a chain rule inside of a product rule again. So start with the product rule. So y prime is the first function. So in this case, our first is 4x cubed. Our second is e to the negative x. So 4x cubed times the derivative of e to the negative x. Now that's e to the blob, so we have to do the chain rule. So e to the negative x, or e to the blob, times the derivative of the blob, so times negative 1, plus now the second function, so e to the negative x, times the derivative of 4x cubed, which then is 12x squared. And so cleaning this up, so we've got negative 4x cubed e to the negative x plus 12x squared e to the negative x. And so we can factor out a common negative 4x squared e to the negative x, which then leaves us with just a x in the first term. So x plus 3. So that is y prime in this case.